Hey guys, it's Miss Johnson here, and I'm here to bring you our notes for Unit 1, Notes 5. Our learning target today is I can graph linear inequalities. So we're making sure that we are able to graph linear inequalities. So let's just start out with some review of graphing equations. Up at the top of your notes page, go ahead and grab your notes page if you don't have it already. Starting with number 1, I want to graph that equation. Now when I'm graphing equations, I need to make sure that they are in y equals mx plus b form. So that's the first thing that I'm going to do is make sure they're in that form. Number 1 is I have y equals mx plus b. Here's my b, there's my slope. So I start with the y-intercept. Y-intercept is positive 5. And then the slope is negative 3. I'm going to go down 1, 2, 3, and over 1. And I do that a couple times so that I have a few points to make a nice straight line. Over 1, 1, 2, 3, and over 1. So my line should look something like this. And there it is. In number 2, now I'm not in slope-intercept form, so if the first thing I need to do is get that y by itself, so I'm going to add x to both sides, and that gives me, I'll just jump down, move this down a little bit. That gives me 3y is equal to x plus 6, and then I divide by the 3. So I have y is equal to 1/3 x, so 1/3 becomes my slope because I had a 1 in front of that x there, and then 6 divided by 3 is 2, so plus 2. So in this case, I need to go up 2, and then the slope is 1/3, so I go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Or remember from that point, we can also go down 1 and back left, 1, 2, 3. Down 1, 1, 2, 3, back. And there we are. So there's the line there. Now this third example, when we're looking at an equation that says x is equal to 5, we've got no y value or y variable. Since there's no y variable here, we're just going to go over to x equals 5, which is over here on our line, over 1, 2, 3, 4, 5 to the right. That's my x equals 5 value. And what this is saying is that for every y value, it doesn't matter what the y value is, my x value is going to be 5. So my y value could be 1, x is still 5. Y value could be 2, x is still 5. Y value could be negative 6, x is still 5. This ends up giving us a vertical line. So whenever you're missing that y variable, that means you're going to end up with a vertical line. And just a review for us, the same is true if you have, I should say vice versa, the opposite is true. If you have no x variable, then you end up with a horizontal line. So those equations look like y equals something. They'll say y equals some number with no x variable. So that's just graphing equations. Now here's why inequalities are different. So we looked at solving inequalities with one variable. We talked about all of these symbols. Now this page isn't on your notes. It was on your notes a few days ago, but this is just a reminder of what these 4 symbols mean. You've got less than, you've got greater than, less than or equal to, greater than or equal to. But if we're looking at inequalities with 2 variables, okay, 2 variables, I can't just solve for 1 variable because there's 2 in the equation. So since there are 2 variables in the equation, meaning we have an x and a y, x and a y, x and a y, okay, so they look something like this. They're going to have inequalities with 2 variables. Since they have 2 variables in them, I can't just solve them like normal. Can't just solve them and get the variable by itself. I have to graph them to get the solution. Okay, I have to graph them on a coordinate plane to get the solution. Okay, so that's what inequalities with 2 variables are. They have 2 variables in them. I can't solve them like normal. I have to graph them in order to get to the solution. And we're going to graph them on a coordinate plane. So earlier last week, we looked at inequalities where we just graphed on a number line and we would put in the filled in or open circle and we'd shade where they needed to go, and that was all fine and great. But when there are 2 variables, now I need a coordinate plane because I have that second variable. So let's take a look at our steps. Okay, the first step that we're going to do when we look at graphing an inequality, the first step is I need to put the equation in slope-intercept form. the equation in slope-intercept form. In other words, that means get y by itself. Okay, so that's my first step. Then the second step would be to decide the line. I need to decide what kind of line I'm going to make because there's two different possibilities here. I'm going to use a dotted or sometimes called dashed line if I have less than or greater than. This is in lieu of an open circle. This is also when we would use an open circle, but it's going to look like a dashed line. And a solid line if I have greater than, less than or equal to, and greater than or equal to. So this was when we would have a closed circle, and on a coordinate plane, it's going to be a solid line. Okay, so that's the next thing I have to do. So I have two decisions to make. First one is decide what line to make. The next thing I have to decide is where am I going to shade? Am I going to shade up from the line or am I going to shade down from the line? Well, if I'm looking at some sort of version of greater than or greater than or equal to, then I'm going to shade up from the line. If I have less than or equal to, then I'm going to shade down from the line. So slope-intercept form, decide the line, decide the shading, and then the last thing is just put it on the graph the inequality. Okay, and that's where you implement those decisions. What line did you use? Where did you shade? Just a note about the shading. If you're not sure of where to shade, pick a test point. Just pick any point on the coordinate plane. I typically use 0, 0. Plug it into the inequality and see if it's true or not. If it's true, that's where you shade. If it's not true, then you have to shade the other side. Okay, so let's take a look at number 4. I have the inequality y is less than or equal to 2x plus 3. The first thing that I want to do is I want to put it in slope-intercept form. Well, if I look at this one, y is already alone. Here's my slope, here's my y-intercept, and I'm already done with that. The next thing I have to do is decide the line. So in this case, I'm looking at less than or equal to. Less than or equal to is a solid line. It's hard to see that red solid line here. And then I also, my next step is to decide where I want to shade. Since this is less than or equal to, I'm going to shade down. Okay, so I've made those decisions. Now I'm going to put it on the coordinate plane. I had to get rid of this little guy so it's not in the way there. All right, so I start with the y-intercept just like we did with equations. Go up 3 spots. And again, just like we did with equations, I use the slope, count up 2 and over 1, up 2 and over 1, or I can go down 2 and back 1, down 2 and back 1. It's really important with inequalities because you're shading that you go across the whole coordinate plane with your line. So when I make my line, which is going to be solid line here, I'm going to go across the whole coordinate plane. So I didn't just stop where I stopped making the points, I went across the whole thing. And then shading down. So the way I think of this is imagine yourself standing on this mountain. If I were a little person standing right here, sorry about that, we got the bells in the background. If I were a little person standing right here, where would I go to go down from the mountain? I would go down below. So the shading goes down here. And there it is. There's our inequality that has two variables. Let's do one more example together and then we'll come back tomorrow and finish the rest of our notes. So number 5, again, I need to start with making sure that my y is by itself, but in this case it is. Then I need to decide what kind of line. So I look at the inequality symbol. The inequality symbol is greater than. So that tells me I'm going to use a dashed or dotted line. Sometimes that's called dashed, sometimes we call it dotted. Both mean the same thing, it's just that you have space in between. And so that's the line that I'm going to make. And then the other decision I have to make, this is my step 3, is where am I going to shade? Since this is greater than, I'm going to shade up from the line. So now I graph it. My y-intercept is -6. So I come down to -6. And then the slope is 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and so on. Again, it's really important that you go across the whole coordinate plane. Remember that you want a dashed line. This is where I make mistakes, and if I'm using a pen, then I am in trouble because I always just automatically draw the whole line in, but this one is dashed, so I've got to leave some space like that. So I have a dashed line going through those points, and then I want to shade above them. So again, imagine yourself standing on that mountain. Where would you be if you jumped up in the air, if you went up? I'd be up here. So that means this is the whole piece on that side of the line that I want to shade. It's above that line there. All right, so I'm going to go ahead and stop our notes at that point. Please hop back to Schoology and take the quiz for Notes 5. Thanks for watching, and I will see you all tomorrow.